Hello and welcome to another video. In this video we're going to be working on minimum amount of time to collect garbage. And so you're given a zero indexed array strings garbage, where the garbage I represents the assortment of garbage at the ith house. And we can have three types of garbage. We can have metal, paper, or glass garbage, and each letter represents one unit of that garbage. Picking up 1 unit of garbage takes 1 minute, and you're also given a zero indexed array travel, where travel I is the number of minutes needed to go from house I to I plus 1. So we have 3 garbage trucks. One picks up each types of garbage, and each one starts at 0, and they have to visit each house in order, meaning to get to like house 2, you have to go to house 1, but you don't have to go to every single house. You also don't have to, obviously, you're not picking up garbage from a house where like you don't have that garbage, but you have to go through it. So your house is arranged in a line, essentially, and the travel tells you the distance between each house. So only one garbage truck may be used at any given moment. While one truck is driving or picking up garbage, the other trucks cannot do anything. Return the minimum number of minutes needed to pick up all the garbage. And so in this first example, we have 4 houses, so we can actually label them. So this is house 0, house 1, house 2, house 3. And basically in the travel, the way it works is to get from 0 to 1 costs 2, from 1 to 2 is 4, and from 2 to 3 is 3. So the actual like index in travel is how long it takes to go from the ith house to the house after. So like travel 2 is how long it takes to go from 2 to 3 and so on. And travel 0 is how long it takes to go from 0 to 1, and you start at house 0. So they kind of explain the routes here. And so basically the paper truck has to go to house 1, pick up the trash. So to go to house 1 costs 2, picks up the trash, which is 1. Then it goes to house 2, which costs another 4, pick up the trash. So we have 8 here. Then the glass garbage truck has to go to these 3 houses, right? So it has to pick up from house 0, which just costs 1. Then it has to go to house 2. So it needs to go to house 1 and 2. So you add these together. So it's going to be 6 plus 1 to pick it up. And finally to the last house, there's 3 plus 1 to pick it up. And so you have 7 plus 4, 11, 12, right? If I did that right. It says, oh, right, because there are 2 pieces. That's the other thing, yeah. So if there are 2 pieces of glass, it takes 1 per piece of glass. So this is 2. So it's 13. And there is no metal, so you don't need the metal one. Now let's go to the second example. So once again, we have index 0, 1, 2. And this is to go from index to house 1 to go from house 0 to house 1, and this is to go from house 1 to house 2. So we have the metal one that needs to pick up 3 pieces of metal. Then it needs to go to the next house, which costs 3 to get to, and then pick up 1 piece of metal. And then we have the paper, which starts at house 0, needs to go to house 1, which costs 3, pick up some paper, go to the next house, which costs 10, pick up some paper. And finally, the glass. So it needs to go to house 1, pick it up, and house 2, pick it up. So house 1, pick it up, house 2, pick it up. So here we have 7, 15, and 15. So altogether it's 37. So basically you can kind of just simulate every single route or every single path for a truck. And let's go back up to the constraints. So the garbage length is 10 to the 5th, which means something like DP probably doesn't work. You can actually, if you can do DP, if you do garbage length and the other dimension is travel, that'll work because it's 10 to the 5th by 10 squared. So that would pass. So something like DP actually would work. And then the other things, right? So when you're trying to minimize or maximize, the main things you're looking for is like sliding window, 2-pointer, some kind of like array traversal. So the main thing to note in this problem is basically when you are picking up trash, you don't have to go to every single house like I said before, right? So we literally just have to say, like, we can kind of simulate the truck movement. So let's kind of draw an array of some stuff, and we'll show you how to like simulate truck movement essentially. So let's say we'll have a bunch of stuff. So let's say we have like MP here, then we have like G, then we'll have, and I guess I don't need like string, right? So we'll just say like, yeah, metal paper here, we'll have G at this index, then we'll have MP again, maybe, MG, and let's see, we'll have like PPP, and m. This is enough. Let's index these. We're not going to draw out the travels array, but we're kind of going to explain how we need to use it, right? Because there's no point in like making the travels array, but we're going to figure out like how to use it. So essentially what we need to do is for every truck, like let's say we have metal, we can just go through this array and like we're just going to go element by element and check what kind of trash it has. So we're going to have 3 trucks that start at location 0. So we'll say M starts at 0, P starts at 0, and G, they all start at 0. Let's make this travel array, might as well, because then we can get a realistic. So let's have a travel array of like just something simple, right? Like even this is fine. 1, 2, 3, 4, 5. Okay, and we'll index these as well. And remember, the index is how long it takes to go from that house to the one after, right? So index 0 is how long it takes to go from 0 to 1. 1 is how long it takes to go from 1 to 2, and so on, right? So 1, 2, 3, 4. Okay. So now we're basically going to simulate our routes, and we can actually do all the trucks at the same time. We know they can't travel together, but what we can do is we can just add up all the truck movements at the same time. So we're going to do a one-pass traversal, and we're going to add up all the truck movements. So we're going to record where the trucks were. And now the other thing that we need to also do is, because a truck can move from one house to another, right? So these are all the like distances from like 1 to 1. But what if it has to move from here to here, or from here to here, or from here to here? You don't want to have to keep like recalculating these things. You want to find an efficient way to calculate movement from any one house to another. And because the distances never change, right? Like they just give you this travel array, it never changes. You can actually use prefix sums to get the travel distance, and then you can calculate the distance from any one house to any other house in O of 1. Because otherwise we'd have to say like, okay, well, to go from 1 to 4, we'd have to start at 1, and then we'd have to add all these up. And then to go from like 0 to 3, we'd have to like start at 0 and add all these up, right? We'd have to keep adding up a bunch of things. So we're essentially like adding things up. But with prefix sums, you don't have to do that. So what prefix sums is going to look like, so we're going to make another array, call it P. I guess we have P, let's call it like pre. And essentially the way prefix sums works is you just keep track of a cumulative total up to a certain point. So the cumulative total up to house 0 is going to be 0. The cumulative total up to house 1 is going to be 1. And then we're essentially going to add, so the cumulative total up to this house is going to be 3, right? Then 6, then 10, then 15. And so what this means is the total to get to house 0 from the very start is 0. The total to get to house 1 from the very start is 1. Total to get to house 2 from the very start is 3. Total to get to house 3 from the very start is 6. And then house 4 and house 5, right? So that makes sense because this is actually the case, right? So essentially, to get to the last house would cost all of these combined. To get to the second house would be this. And now, if we want to know how long does it take to get from, let's say, house 1 to house 4, we can easily do that because we can say like, okay, well, it takes 10 to get to house 4 and it takes 1 to get to house 1. So the difference is going to be the time it takes to go from one to the other. So with this prefix sums array, we're now able to know how long it takes to get from one house to the other in O of 1. So we're going to build this up for T. We're going to build this up for the travel. And then we're going to use it to get our travel times fast. And now we can easily simulate, at least hopefully I built it correctly, but you get the idea. You basically just keep a cumulative total, and then you can just subtract indices to get like to get how long it takes from one to go to the other. I think I did the math right, but I'm not 100% sure. But that's basically how prefix sums work: is you just keep track of a cumulative total, and then it lets you get a sum of a range, like this range or this range or this range, by just taking 2 of these numbers and subtracting them in O of 1. So it's very useful when and the important thing is your numbers have to not be changing. Like if I change these distances, then this no longer works, right? Because anytime I change a distance, all of these are going to work. So for that, you'd have to use something more complicated. But for just a range sum query, you can do that using prefix sums. So now that we know that, let's kind of walk through what's going to happen here, essentially. Okay. So we're going to start over here. And we're also going to have a result variable. So let's just have a result over here. We'll make it 0 for now. So basically, what we're going to have is we're going to say, okay, well, let's see what kind of things we encounter. And then anything we encounter, the truck responsible for that will calculate how long it takes to move there and then to pick it up, right? So we're going to say, okay, we encountered metal. Where's metal? Metal's at 0, so it doesn't need to move, but it needs to pick up the metal. So now this to pick up the metal costs 1. So let's actually move the result over here, just because we're going to be updating it a lot, right? So let's move the result over here. We'll make it 0, and then we'll just add a bunch of stuff. So we're picking up metal. I remember our metal truck is at 0 currently, so we're already there. So we need to pick up metal, which just costs 1. And our truck is already there, so we don't need to move it. Now we have paper, so our paper, we need to pick up 1. It's already there. Now we go to the next house and we say, okay, well, we need to pick up glass. Where's our glass? It's at 0. We need to get to 1. So in order to get to 1 from 0, we need to say, what's the prefix sum of 1 minus the prefix sum of 0? So it's going to be 1 minus 0. So to get to 1 from 0, it's going to be 1, right? Plus the 1 that it takes to pick up the glass. And now we need to update the glass position over here to be at index 1. So then we go to the next house and we say, okay, well, we need metal. Where's our metal? It's at 0. We need to get to 2. So that's going to be 2, this index 2 minus this index 0. So that's going to be 3. So plus 3 plus 1 to pick up the metal. And then we need to update where our metal location is, right? So now our new metal location is actually at index 2. And same thing for paper, we're going to update it to index 2. It was at index 0. So in order to go to 0 from 0 to 2, it's going to be the same as the metal. So it's going to be 3 to get there and 1 to pick up the paper. Okay. Now we go to the next index. And we need to pick up the metal. So where is our metal? It's at 2. We need to go from 2 to 3. So we'll do 3 minus 2. So we have 3 here. So we'll add 3 plus 1 to pick it up. Let's scroll down a little bit so we have more space. Now we need to update our metal because now we're at 3. And then our glass, same thing. So it needs to go from 1 to 3. So we're going to update it to be 3. And to go from 1 to 3, what's 1 over here? Well, 1 is 1 and 3 is 6. So it's going to be 6 minus 1, right? It's going to be the index 3 minus index 1 is to go from one to the other. And so that is going to be 5. So we'll add 5. So we'll just continue on here. Plus 1. This math might not be like correct all the way, but you kind of get the idea. And once we actually code it, it'll be fine. So now we go to the next one. So where's our paper? It's at 2. We need to go to 4. So it's going to be 4 minus 2, which is 7. Plus we have 3 papers. So we can pick up 3 papers, right? So let's pick up 3 papers. And then we need to update our location for paper, which is at 4 now. And yeah, that's it for paper. And now finally our last metal. So metal needs to go from 3 to 5. So we'll update our location to 5. And we will see what the difference is. So it's 5 minus 3, which is 9. Yeah, so plus 9. And to pick it up is 1. So now we need to count all these up. So how many ones we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 ones. So we have 12, 15, 18, 23, 30, 42. So our result is 42 for all of our trucks combined, essentially. And that's kind of the idea. You basically do a simulation where your truck starts at some location, and then every time there is a garbage that your truck is responsible for, you just calculate how long it takes to get there, and then pick it up. And now also, if your truck's already there, like let's say you get this PPP, we can traverse through every letter, and then if the truck's already there, then we'll basically have prefix sums of, like let's say we're at 4, minus prefix sums at 4. So if we're going from 4 to 4, our algorithm is going to handle that. So if our truck's already there, it will basically cost 0 to get there. And that's basically all you do. So you just compute this prefix sums for the travel to make sure you can calculate travel from one route to another, any single one in O1. So you don't have to do, this will actually pass if you don't do that, because basically what will happen here is, maybe it'll be close. Actually, I think it'll pass, yeah, because what will happen is you'll basically, like, every time you go from one place to another, it might be like O of 100. So basically your complexity would be like 100 times 10 to the 5th, which would still technically pass. But this is like a cleaner solution. And this is quite useful to know, so let's code it up now. So essentially, we're going to have our result equals 0, and then we are going to make our prefix sums array, and we're also going to make character positions. So we'll do character positions for our letters, because we're going to go character by character, and we'll also make a prefix sums. So we'll say character positions, or maybe this is better, it's like truck positions, or trucks, I guess. Trucks equals, and then we're just going to make a dictionary, so G is going to start at 0. Yeah. P is going to start at 0. And finally, metal is going to start at 0. And then we will have our prefix sum. So we'll call this like travel prefix equals. So the first element is going to be 0, right? The amount of time it takes to get to each house. And then we have to traverse through travel. So we'll say for house in travel. Basically, the way prefix sums works is it's going to be, the new entry is going to be the old entry plus the new location that you're going to, right? So it's going to be, so prefix sums of n is prefix sums of n minus 1 plus travel of n, or the new location. So we'll say travel prefix dot append travel prefix minus 1 plus the current house we're on. Now that we have that, we have our prefix sums. Now we basically need to enumerate garbage. So we'll say for I house and enumerate garbage. For character in the house, we can just check where the truck is by using the dictionary, right? So we can just say result plus equals travel prefix I. So this is like where we currently are minus where the truck used to be. So this is going to be travel prefix. So whatever truck this is needs to go here, and the actual travel prefix we need to look at is going to be travel prefix of trucks, and this is going to be the character, right? So like if we are at garbage, we need to figure out where garbage was. So this will be travel prefix of trucks at some location, and whatever that location is, that's going to be, and essentially this will be, so basically it'll index into the travel prefix array at wherever the truck used to be. So this is going to be char. Yeah, and then it's also going to cost 1 more to actually pick up the garbage, right? So it's travel distance plus 1 to pick up the garbage. And then we also need to update where our truck is. So we'll say trucks char is now going to be at I, right? So wherever it was before, it's now at I, and that therefore, if we have a bunch of letters in the same house, it's going to cost us nothing to get here from now on. So essentially, we're moving a truck when we need to go to a new garbage location. Otherwise, we're not moving it, right? So we're moving it as little as possible. Okay, and then now we return the result. And let's see if we have any errors. Looks like we're good. Okay. And so we have a pretty efficient solution. I think I don't see how you could do it any faster than in O of n. You might be able to do some kind of like other small optimizations, but basically I don't think you can do this better than O of n. So for the time here, so making this travel prefix took O of travel, right? So if we go back to the description, so O of travel, but O of travel depends on, basically travel depends on the length of garbage. So let me see here, travel length, garbage length. Actually, sorry. So actually, I take that back. I think this actually wouldn't pass if you didn't do a prefix sums, because travel can be as long as garbage, right? So travel and garbage are basically the same length. So if garbage is 10 to the 5th, I don't think this would pass, because then it would be like for every single thing you're moving 10 to the 5th, so it'd be like n squared. And then I don't think it would pass. So I do think prefix sums is actually mandatory. So time, basically, we have to compute this prefix sums, which is the length of, O of n, length of garbage, length of travel. They're basically the same. So I did misread it a little bit, where this is travel I, and travel length is actually garbage length, basically. So it's going to be O of n to travel through it. And then also you have to figure out like how many letters are in each thing. And so for each letter, you also have to read the letter. So let's see how long that is. So garbage length I is 1 to 10. So if it's only 10, we'll just say it's O of n, because basically, the most it can be is 10. You could say like O of n times, average element or average string length or something. in garbage, something like that. But because it's only n, or because it's only 10, I'll just say this is of n. And the space, so we do have this trucks and we do have this prefix sums array. So prefix sums is of n, right? To get the prefix sums for an array of length n is going to be of n because you're computing it all. And that's, yeah, I think that should be it. So yeah, small error there that actually, yeah, this wouldn't work without prefix sums. It's mandatory for, worst case problems. But once you know that, probably closer to an easy problem, to be honest, because you can basically do most problems that you can do the straight up simulation for is pretty straightforward, especially if the simulation is pretty easy. Like usually the actual simulation of the problem is too big to fit the constraints, so then you have to do like some optimizations. But this one you can basically do an entire simulation and it works. Yeah, so that's going to be all for this one. So hopefully you liked it. And if you did, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.